Those gone, you're going to get a real quick overview. Since it was Peter, you can send him cookies later, who reminded me to record this. We have shorter ways of proving two triangles similar, then proving that all corresponding angles are congruent and all corresponding sides are proportional. And the first one is the angle-angle similarity, which means I need two corresponding angles congruent to two corresponding angles. So right down here, we did some examples. And your fellow classmates will be happy to help you out if you get confused on these. In the first one, we had to figure out what the third angle was. And when we figured out the third angle, because we know in a triangle all the angles add up to 180, we discovered we had two corresponding congruent angles. In part B, we use the parallel lines, and when we have parallel lines and transversals, we have some congruent angles, and that one ended up being similar. In 1A, we figured out the measure of each of the angles because we know we have acute complementary angles, and we discovered we did not have two pairs of congruent ones. And in 1B, we had parallel lines again, and those parallel lines had some congruent corresponding angles. And so now we are all caught up, and we are going to see the second way of proving that we have triangles that are similar. Side, side, side similarity. When we did congruence of triangles, we just used these three letters, SAS, or angle, side, angle, ASA. But we can't just use SSS because we might be implying that that is a congruent statement. So when you use this, if you ever have to use it in a proof, which we'll be anxiously awaiting, we would say SSS similarity, so that we are identifying this proves triangles similar. We're not proving triangles congruent. Because if you have two triangles and all three corresponding sides are proportional, they're not congruent, they're proportional to each other. So they have just written a proportion. They matched up all the corresponding sides and they all have the same ratio. Then they're similar. Doesn't make them congruent, it just makes them similar. And then our third one is an SAS, but it's a side-angle side similarity. SAS similarity. So if I have an included angle, notice our angle is between the two sides. Our included angle, it's formed by those two sides that are proportional. So we have to do a double check here. We have to have two corresponding sides proportional and the angle between them, or the included angle, we say, is congruent. So now we have three ways. So let's come down here and see if we can try out any of those three ways. Actually, we're just going to check the side, 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 and side, angle, side similarity. And then we're going to write a similarity statement, and we're going to explain our reasoning, which is going to be just one of those two theorems. Let me back up a minute. These things are theorems. They can be proved from that last postulate. So how about part A? As I look at this, I want you to tell me which makes more sense, to try the side, side, side similarity or the side, angle, side similarity. Side, angle, side. Side, angle, side? Well, really, there was not a wrong answer. I do have vertical angles here, don't I? So I could try side, angle, side because I have a couple of sides that form those angles. But you also may notice that they have told me all three of the sides as well. So on this one, I'm going to actually use the side, side, side similarity because I'm going to use a side, angle, side later on. So let's try it out. 5, that length would have to correspond with which one? 5 is in the top. What would it have to go with in the bottom one? 12.5. 12.5. How do we know?
Because if you rotate it.
Because it makes sense. Some of you can see the rotation. If I rotated that top one, you can see how it matches up. What's another reason? Maybe I can't see the rotation quite so easily. It's the shortest side. It's the smallest value. So it must go with the smallest value. So I'm going to try the 6. What does that have to correspond to? The 15. And then I am going to do what's left. 8 and 20, isn't it? Now, how do I check again to see if these are actually proportional? I can divide. Why don't you do that for me real quick? Get your calculators out. 5 divided by 12.5.
0.4.
0.4, exactly?
Yes, sir.
6 divided by 15.
0.4.
You just making that up?
No.
8 divided by 20.
0.4.
All right. So the check that I did verifies that yes, they are by the side similarity. Now they want us to write the similarity statement here. So I'm going to do triangle PQR. Triangle PQR is similar to triangle. You have to match it up. What does angle P match with?
S.
It would be S. This is rotated all the way down, if you can think of it that way. P goes with S. Q goes with
T.
T. And the only thing that's left is R. So we have our similarity statement as well. All right, B. I'm going to try the side angle side. Where am I getting my angle from in part B?
A.
A, angle A. They share it. So right there's the angle. So I know I've got my angle. So let me go with 8 on the top triangle. What does that pair with or correspond with? 12. Where are you getting 12 from?
8 plus 4.
8 plus 4. In order to have the big triangle, I have to take the complete side. This big triangle is right there. So let's see. Does it equal 10 to 15? 10 to 15. I want to do a different method. I want you to reduce 8 12. So what goes into both of them? 4 does. So what does it reduce to?
2/3.
2/3. I want you to reduce 10 15. So what goes into both of them? 5. What does it reduce to? They are proportional to each other. So by the AS similarity, side angle side similarity, we have triangle AEF. AEF is, that's a squiggly line, similar to triangle
ACB.
ACB. So far everything works. That's usually how it goes in math. Everything works. What are we going to check on 2A? What are we going to check? Which theorem? Side. 8 goes with?
No, 6.
8 goes with 6. 12 goes with 9. 16 goes with 12. I'm going to reduce again. Reduce 8 6 for me. 4/3. Reduce 12 9 for me. 4/3. 3 goes into it. Reduce 16 12s.
4/3.
4/3. 4 goes into it. Beautiful. Side similarity. It works. 2B. What can we check? Which one? Side, angle, side. Side, angle, side. Where's my angle?
W.
The vertical ones, right over there. 10 would match with 20. It's the shorter one. It's the shorter one. 10 matches with 20. 11 matches with 22. What do they both reduce to? 1/2. Check. Side, angle, side. See, I told you everything in math just works. If only life was more like math. All right.
No, we'll have to solve problems. We'll have to solve problems.
In the figure. You don't think you have to solve problems in real life?
Why have problems if you cannot?
In the figure, angle ADB is a right angle. Angle ADB is a right angle. So sure enough, which of the following would not be sufficient to prove that these two triangles are similar? ADB, that's the one on the left, and CDB, this little one on the right. So if we look at part A, they are giving us two proportional sides, AD, BD. AD, that's this one right here. BD, that's this one right over there. Is it possible for us to rotate that little one where it would match up? Yeah. BD, CD. BD, I'm going to do an X. And CD. Now the X is for the left triangle. And CD. If I rotated that little one, yeah, those match up. Would that prove that those were similar?
Mm-hmm.
Yes. By what reason? By side angle side. This angle is also 90. By side angle side, that one would work. So let's try this. If I have AB and BC, AB, I'll use an X this time. BC, do those match up? Yeah, they're both the hypotenuse, I guess we would say, hypotenuses. BD and CD. BD, that's this one. CD, do those match up? Yeah, if I rotated that little one again, would that be enough to prove we are similar? What reason? I have to have the three sides. Do I have the three sides? No. This one would not prove that they were similar. If I rotate this down, I do have two corresponding sides, but they didn't tell me anything about those angles right over there. So that would not be enough. Now I want to see if this is enough and why it is enough. There's only supposed to be one that doesn't work. Angle ABD is this one right up here. Angle C is this one right down here. Now that ABD was just in the big triangle. Is that enough? Prove they're similar. What reason? Angle similarity. Don't forget about that one. All it takes is two angles. Gentlemen can handle it back there without being moved. What have they shown on D? I want you to think about D. What have they shown? What reason would prove that those triangles would be similar? Side, side, side. They've told us about all three corresponding sides. AD, BD, AD, and BD match up. Rotate that little one down. BD, CD. BD in the big one, CD in the little one, match up. AB, BC, AB in the big one, BC in the little one, side, side, side. So this one does not. The others are enough to prove by the reasons that we have. So here is the little summary that we have. Oh, this isn't a summary at all. This just tells us that we can use the reflexive property when we're talking about things that are similar. We can use the symmetric property. They've illustrated it. We can use the transitive property. So they're leading us up to proofs again. We can use all those other things when we're talking about similar triangles. So they don't have to be just congruent triangles. Well, they want us to figure out some measures. QP. They have called it X down here. They want us to figure out this measure. First tell me, do I have similar triangles in 4A? And I want to know the reason then, if I do. We just have three reasons. Angle, angle, similarity, side, 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 similarity, side, angle, side, similarity.
Yes.
By what reason?
Angle.
By angle, angle. There are a couple ways we can do it, but they share that one, and then there are some corresponding ones. We also have some corresponding on the other side. Angle, angle, similarity. Don't forget that I have to know I have similar triangles before I can do things like setting up proportions to prove or to find the value of X down here. Now, is X the length of a side? Is it the side of a triangle?
No.
No, it's not. So what is X part of that is a side of a triangle? What do I have to put with X to make it a side? 5. X plus 5. Now that's that whole side over here, X plus 5. What does it match with? That's the big triangle. What does it match with in the little triangle? 5. This big side matches up with that small side with 5. So that must be proportional to, help me out, 3 3/5 plus 6. Now give it to me as a mixed number, it's easy. 9 3/5. 9 3/5 to what? To 6. The big triangle, the whole thing, to the little one. Now we need to find the cross products. Before I find the cross products, I really don't like mixed numbers. Change this improper. 5 times 9 plus 3, what do you get? 48 fifths. 5 times 9 is 45, plus 3 is 48. I'm going to call this 48/5. So now I'm going to set up my cross products. X plus 5 times 6, I'm going to write the 6 first, must equal the 5 times the 48/5. That's going to be a beautiful fraction in just a moment. Distribute here. 6x plus 30 equals what? 48. Those 5's just cancel out. Equals 48. So we can subtract 30. 6x is 18. And what is x? 3. X must be 3. We figured out what x was. So on this, an MP. Where's our M? Oh, MP is the whole length. That's going to be hard. X is 3. Oh, they wanted QP. Oh, that was X. That's QP. Make sure you're answering the right question. MP, what's that length?
I'm not sure.
Well, you're not sure. Somebody else in the class can help.
8.
8. 5 plus 3 makes 8. So let's try this one over here now. Tell me why I know those are similar triangles. Angle similarity. Let's go ahead and put away the distracting toys. Angle similarity. I've got vertical angles, and they already gave us this one right over here. So I can set up a proportion. Let me just start with this x plus 6. I need to know what it goes with. Andrew, you got what it goes with?
X plus 6.
2x.
It goes with 2x plus 6. There are two ways to tell. If you can figure out the rotation, you can rotate it either clockwise or counterclockwise. Or as I look at it, I notice it's between the 1 arc and the 2 arc on my angles. 1 and 2 arc, what's between it? This one is. It must correspond to 2x plus 6. Now, what's the rest of my proportion?
8.
8 to 10. 8 to 10. I would reduce that. What does that reduce to? 4/5. Now you don't have to, but if you reduce it, you have smaller numbers. So cross products again, I'm going to take 5 times x plus 6. Must equal my 4 times 2x plus 6. So 5x plus 30 must equal our 8x plus 24. I'm going to subtract 5x and give me 3x. Going to subtract 24 and give me 6. What's x? 2. X is 2. Now they wanted to know WR. Tell me the length from W to R.
8.
8. 2 plus 6 is 8. They wanted to know RT. Tell me the length from R to T. R to T is going to be 10. 2 times 2 is 4 plus 6 more is 10. Similar triangles can be used to do all sorts of nifty stuff. Haley is estimating the height of the Superman roller coaster in Mitchellville, Maryland. She happens to be 5 feet 3 inches tall. Now I want you to notice in their picture here, instead of calling her 5 feet 3 inches, they did 5.25 feet. We can't mix our units. So how'd they get 0.25 from this 3 inches? 3 out of how many inches in a foot?
12.
3 out of 12. 3 twelves is 1/4, 1/4, 0.25. Her shadow is 3 feet long. So there's her shadow, 3 feet long. If the length of the shadow of the roller coaster happens to be 40 feet, so she's standing right there at the beginning of the roller coaster, and her shadow and the roller coaster shadow are overlapping each other, but she can see her because she has a head and the roller coaster doesn't. If the length of the shadow 40 feet, what is the height? How tall is that roller coaster? So she is trying to figure out this. What is the height of that roller coaster? Does she have two similar triangles when she makes the triangle here for her, and then there's a big triangle for the roller coaster? Why are those two triangles similar? Now, how do we know we have parallel lines? Because the sun is in the same place for her and for the roller coaster. And so the sun is shining down at the same angle. You can think of those as parallel lines. Another way, we call it later on in geometry, the angle of elevation is the same. When you're on the ground looking up to the sun, that's an angle of elevation. Angle, similarity. So let me start with the height of Haley, 5.25. What does that correspond with?
X.
X, or I'm going to call it H, the height of the roller coaster. Finish it out for me. 5.25 to H equals
3 to 40.
3 to 40. You have to go, I'm going from the small to the large, small to the large. So cross products, 3 times H equals 40 times 5.25, and then we can divide by our 3 to get rid of it over here. How high is the roller coaster? 70, exactly? 70 feet tall. Similar triangles. A little bit later, I'm going to give you an opportunity, but I'm going to wait until your friends are back. I'm going to give you an opportunity to measure something using some stuff we know in geometry for some extra credit. Here's the summary of what we learned today. The angle, angle, angle similarity, the side, side, side similarity, and the side, angle, side similarity.